Thank you for joining the Pi community track. Our next speaker is Federico Capoano. Federico is an OpenWisp core developer, and his talk is Applying the Unix Philosophy to Django Projects, a report from the real world. So
hi, everybody. Thank you for coming to my talk. I'm Federico Capuano, also known as Nemesis, OpenWisp core developer, and I'm working on public Wi-Fi. I've been working on this at Cineca since 2012. So, what is OpenWisp? OpenWisp is a set of software modules that can be used to deploy and manage wireless networks, public Wi-Fi, backbone, mesh networks. The first generation of the OpenWisp project started in 2008, and it was specifically focused on public Wi-Fi, that is, providing internet access for cities, municipalities, public squares, and things like that. There was a fast growth of features that were requested from the clients, which used the first generation of the software, and this led to an unmaintainable situation because features were added quickly to the code base, and we encountered a few problems. The main issue of OpenWisp 1 was that the main modules are in reality monolithic Ruby on Rails apps, and the code is tightly coupled because the logic of these apps calls into each other. So to implement changes to a specific component, you affect also many other components. And there's also duplicated logic because each of these Rails apps re-implement the user model and some other logic differently instead of sharing it. So there is a lot of duplicated logic. Policy is not separated from mechanisms. This is a concept that I'm going to explain a little bit more in detail later. But for now, just keep in mind that some features of OpenWisp 1 would have had a better life in a separate dedicated project. So it could have been used also by external projects or communities or organizations. Think about the engine which generates the configurations for the access points or the routers. In OpenWisp 1, this logic is embedded in the Ruby on Rails app. You cannot use it outside of Ruby on Rails. And it's a shame, because that feature was a very interesting feature that would have been interesting to share with different projects that work on similar issues, but it was not possible. So all this situation led to a lot of complexity, which is hard to manage, and led to negative consequences for OpenWisp 1, very negative consequences. The first is the classic giant ball of mud problem, in which many features, there are too many features in a single code base. It's hard to add new features in a clean way, and it's hard to maintain over time. When you need to upgrade dependencies or fix bugs, you have this giant pile of mud, and basically you are scared to touch it. And this also brings you in a situation of inflexibility, in which it's hard to extend the core without changing it, and it's hard to readapt and reuse the software in different contexts. And the specialized features, as I was telling you right before, available in the code base are not easily reusable. Another problem that we had is that we got little or no contributions. Complexity scared away potential external contributors, and we only got low-quality patches that were never merged. This also brought to increased costs to keep the project alive, and many years of work risked to fade into oblivion, which is a shame. There was also a lot of duplication of efforts because similar projects which needed to do similar, to implement similar features could not reuse our software, so they re-implemented their own with similar problems, and we were not able to create an ecosystem of interoperable tools. And this is not good, and Nicola must not be happy for this. And this cannot be, there must be a better way. So I started thinking, I started reading more, and it came to my mind, the masters came to my mind. In this photo you can see Dennis Ritchie and Ken Thompson, the authors of the original Unix operating system and the B and the C programming languages. So, what is the Unix philosophy? Let's see a quick overview, and then we will gradually go into more detail. So, the Unix philosophy is an approach to software development which is bottom-up, it's pragmatic, it's grounded in experience, and it's founded in an empirical skepticism. It evolved in the Unix community since 1970, so it's very mature. It's change tolerant because it was born during the digital revolution. It had to keep pace with the dramatic evolution of technology. And in short, what are the main concepts? The most important concept is do one thing and do it well. Break down big problems into smaller problems, write simple programs that solve one problem well, and write programs that work together. Value simplicity and maintainability over performance and complexity. What advantages does this bring? Saner development, because solving one problem at a time is easier. Maintainability, because maintaining a simple program is less expensive. Usability, because such a program is easier to use, which is also easier to read and understand. This also will allow you to move with more agility, because it will be easier to readapt it to new requirements. And it's easier to reuse, and it can be more easily reused by other people, which will more likely, if it's written well and documented well, contribute to it instead of re-implementing their own. After a while, you will see an ecosystem to develop with these tools that are available. And this ecosystem, it's like having basic Lego building blocks, which will allow you to solve complex problems faster. Much better. I like this. And so let's go more in detail now. These are the 17 rules of the Unix philosophy that are explained in The Art of Unix Programming by Eric Raymond, which is a book which I suggest to you. First rule, rule of modularity. Write simple parts connected by clean interfaces. I'll go quickly to show you the main rules, and then we will see real-world examples. Rule 2, rule of clarity. Clarity is better than cleverness. Rule of composition. Design programs to be connected to other programs. Rule of separation. Separate policy from mechanisms. Separate interfaces from engines, which means you have a web interface and you have an algorithm that solves a problem, keep them separate. Maybe the algorithm lives better in a separate project that can be reused by other people. You can make this project usable also from other programming languages. So people will be less tempted to reinvent the wheel. Rule of simplicity. Designs for simplicity. Add complexity only where you must. Refuse the temptation of technical machismo. A new technology comes out, it's not necessarily a good idea to put it in your project. Do stuff only when you know it's worth it. Don't add complexity if you're not entirely sure that you can maintain it and it brings you any advantage. Rule of parsimony. Write a big program only when it's clear by demonstration, then nothing else will do. Transparency. Design for visibility to make inspection and debugging easier. And 8, rule of robustness. I had to put a note here because I didn't remember, because this is a little bit more, let's say, less obvious. Software is said to be robust when it performs well under unexpected conditions, which stress the designer's assumptions, as well as under the normal conditions. To follow this rule, you will more likely have to avoid special cases in your code. Rule of representation. This is one of my favorite. Fold knowledge into data, so program logic can be stupid and robust. I will show a good example of this later. Rule of least surprise, you should know this. In interface design, always do the least surprising thing. Rule of silence, when a program has nothing surprising to say, it should say nothing. Rule of repair, when you must fail, fail noisily and as soon as possible. Rule of economy, programmer time is expensive, conserve it in preference of machine time. Rule of generation, avoid hand hacking, write programs that write programs when you can. 15, rule of optimization, prototype before polishing, get it working before you optimize it. 16, rule of diversity, distrust all claims of one true way. Do not believe in dogmas, do not believe in fads, new technologies that are overhyped, always measure and prototype before investing time and resources into an idea. And this is the most important one for this talk because I will provide a lot of examples about this. Rule of extensibility, design for the future because it will be here sooner than you think. This is especially important if you work on an open source project or if you work on a product that is your main product and you have to maintain it over the years. It's probably less important if you do client work in which you deploy something and then you don't touch it for years. So this is much better and Abram approves. And let's see how can we apply this to Django. Some real world examples from OpenWhisk 2, which is a new generation of software modules written in Python and Django, which try to adhere to the Unix philosophy. So first rule of modularity. Try to develop the features, the main features, as reusable Django apps. This is nothing new. If you've been using Django, you already know this. But try to develop one Django app for each group of related features. So if some features are closely related and the models know about each other, each model knows about the other model, it's probably better to put this model in a single app. And document the public API of this app. This relates to the concept of clean interfaces. They also must be well documented, otherwise nobody will be able to use it. Include a license and a changelog, which probably you're already doing. And publish your app on the Python package index, and why not on djangopackages.org, which is a nice way to help your app getting known. So let's go to some examples. The app, which it's the configuration manager basically, in which configurations of routers and VPNs are manipulated. It's called Django NetJSON config. We have another app which we use for public key infrastructure, which we basically use to automatically generate VPN certificates. And this was published as a separate app. To add support for multi-tenancy, which we did recently, that is, different organizations can use the same instance independently from one another, instead of redeveloping something new, I used Django organizations. And I needed to make it a little bit more extensible, so I contributed to it. This means reuse existing projects when possible. 2, rule of clarity. From the Zen of Python, explicit is better than implicit. This is already a widely accepted concept in the Python world. I probably don't need to explain more than this. Rule of composition. Here it gets interesting. So you make one app for a group of features, and then you start combining them into a Django project, and this is the way you can follow the rule of composition. An example of this is OpenWisp users, which is basically a wrapper around Django organizations and some other modules. I will show you a diagram in a bit, which is a little bit more clear. Then we have OpenWisp controller, which depends on OpenWisp users, Django.json config, and Django X509. And the final result is handled by Ansible OpenWisp 2, which is the installer, which deploys the application in an almost transparent manner for the user. Here we have a diagram. You can see Ansible OpenWisp 2 deploys the Django projects. We have two main squares, OpenWisp users, which wraps basically the organization model, the user group and permission models from Django, and Django all-auth, which is used for email confirmation and authentication. Then we have another group, the OpenWisp controller, which has two main apps, the configuration manager, Django.json config, and the public key infrastructure app. There's also a gray square there, which I'm going to talk in a bit. And here it comes the separation. Implement mechanisms as libraries. That is, if you have a complex feature, try to separate it from Django. Try to develop it in a framework agnostic way, so it's more reusable. It's also more maintainable. I'll show you in a bit. Implement policy as configuration. Make these libraries highly configurable, so other people can use different behavior. They can implement different policy by tweaking the configuration. And make these libraries work with data. Clearly define input and output. An example of this was what I was just talking about before, the net.json config, the configuration engine, which is the library which generates the router configuration. It's probably, I will show you in a bit the diagram so you can understand better. The Django.json config is a web interface that uses this library under the hood. Let's see the diagram again. This one is the Django app, which the users enter the configuration from a web interface, and the routers also contact that Django app to download the configuration. But the piece of code that actually translates that data into a real configuration is handled separately. This allows other people to add new features or add support for different firmwares, because we support by default an Linux-based distribution called OpenWRT, but there are many distributions that can be used for routers, even proprietary ones. So we wanted to keep things separated, well abstracted, so other people who use different firmwares can implement their own configuration backend with this library. Here's an example of the code of the library, which doesn't know anything about Django. We import the OpenWRT backend, and we pass a dictionary, which is follows the net.json draft RFC, and we render this configuration, and we get a string which represents the configuration that is then deployed on OpenWRT. It's a very simple example, and we just define the host name, and the system defines the time zone for us by default if we don't supply it. So this is all for the rule 4. Let's go to the next one. Rule 5, rule of simplicity. Start with very basic features. Release your project early, even if you feel it's incomplete. And add one feature at a time as your understanding grows. And add complexity only when necessary. Because every complexity you add that is not needed will backfire later. Let's see a real example of this suggestion. In the beginning, of 2017, we started to release a very featured but basic working feature set of the different modules of OpenWSP2. Then we added many improvements and features one at a time. And as a result of this, as of April 2017, we issued 24 releases of the configuration engine and 25 releases of the web interfaces and 5 releases of the app that manages the VPN certificates and the public key infrastructure. OpenWISP 2 still lacks some features of OpenWISP 1, but the most important features are working well, and releasing early allowed us to start testing the end result with real users, while we are still actively developing, designing, and refactoring the solution, which gives a tremendous insight on how to improve it. So let's go to the next rule, which is rule of parsimony, and which says, write a big program only when it's clear by demonstration that nothing else will do. And this, I translated this to prefer to create new reusable apps when you need to add big features, unless doing this complicates things a lot with no real advantage. As an example of this rule of thumb, I can tell you that I decided to implement the public key management in a new app, but when I added the possibility to manage VPN configurations, I added this feature to the existing configuration manager. Initially, I thought about publishing a new app for this, but then I realized it wouldn't bring me many advantages, and it would complicate my workflow quite a bit. So I added it to the existing configuration manager, and as a retrospective, I can say that it was a good choice. Rule of transparency, which says design for visibility to make inspection and debugging easier. To translate this rule, I try to log unexpected events using the Python logging facility as much as possible, which means that, for example, we log any invalid response, for example, forbidden requests or malformed requests, because usually those are very rare, because the firmware that runs on the routers is controlled by us. So if we get one of these logs, it's either a bug or somebody trying to do something weird, which so far has never happened. So let's see, I also try to prepare a way to show, okay, cool. This is the real code. It's a small function that is called inside the views, which get past the request, error, status, and content type. And it says, it just logs the request. Controller response is a subclass of HTTP response, nothing fancy. Let's go back. Okay, let's go ahead. Also, to follow this rule of transparency, it's good to provide a good default logging and provide support for Sentry. Anybody know Sentry? Cool. I use it. It's really cool. I love it. And I have, oh no, that's just the link to Sentry. Let's see. I have published these slides, so if you're interested in any code example, then you can go and take a look. If I can, maybe. No? I wish I could, maybe. No. Nothing to do. Okay, let's go ahead. You can see the code examples later. So, rule of robustness. I suggest you to add constraints to your reusable app only when necessary. This allows to maybe use the app in a way that you didn't think of, but is still valid. But if you start to add a lot of validation rules, especially strict validation rules, and you don't provide configurable settings to alter the behavior of your app, it will be very hard for other people or for your future self to use the software in a slightly different way from the initial use case. So keep things flexible. Put validation logic, be strict if you need, but don't do it just for the sake of it. Do it if you need it. Here, there are a few examples of settings we provide. Maybe if I can open this. Let's try. I don't think it's possible. Okay. We provide quite a few settings in the configuration manager. The default configuration backends. So if anybody writes a new configuration backend for the configuration engine, they can alter this setting. We have a setting for the VPN backends, the default backend, and if the registration, the auto registration of the routers should be enabled. If another feature which is called consistent registration, and many other features. I try to provide. I can summarize this way. Every time I have a piece of code in which its behavior, I think that I might need something different in the future, I try to put a setting in the very beginning. And this proves very helpful because all different use case scenarios comes up all the time. And doing this in the beginning, when developing, if you use test-driven development, can be pretty easy because it's just usually a flag, true or false, default backends or not. So it doesn't complicate stuff a lot if you keep it simple. Let's go back to the presentation. So now, sorry, I have to go back to the slide because I exited. So we were at, here we are. Let's go ahead. Okay, rule of representation. This is my favorite. Fold complex information in data structures and process these data structures with algorithms. Try to make algorithms framework agnostic if possible. As a real world example of this, I can tell you that in OpenWIS 2, the configuration of routers and VPNs is implemented as a single text field formatted as netJSON. In OpenWIS 1, this configuration data was stored in models and tables. Like, for example, interfaces had their own table, and VPNs had their own table and records for each configuration setting. And this was hard to maintain because networking software evolves constantly, and they add new features every year. So every time there is a new release of the software you want to configure, you have to alter the database, create migrations, data migrations. Well, with the new approach, sometimes data migrations are still necessary, but table migrations are not necessary anymore. It's much easier to change the UI by changing the schema. I'm getting there. I know there are a lot of missing pieces, but I'm slowly getting there. Keep in mind, if you can represent a complex algorithm or a complex setting with a data structure like a dictionary or a list or a mix of them, try to use it because it's also easier to read. Here I can show you an example of netJSON device configuration. It's a simple configuration that tells us the host name, and it tells us that there is one interface, one Ethernet interface with a statically configured private IPv4 address. very easy to read. You can see a similar but slightly more complex example. Can you read? Can you actually read? How much time left? 10 minutes, okay. It's a slightly more complex, and this is the advanced mode of the application in which users can enter configuration data directly. When it's processed, that net.json it generates the configuration output, which is this one. This is the preview mode. You can see the final configuration which will be deployed on OpenWRT. And this interface just uses the configuration engine under the hood. Rule of least surprise. This has become a widely accepted concept. I don't need to explain it very much. Just remember that your program surely has an interface, which can either be a web interface, a graphical user interface, touch screen, or voice interface. Just when you design these interfaces, don't be too creative because it can be bad for the user experience. Rule of silence is not hard. Just don't make your app annoying. Don't get in the way of the user. And rule of repair. From the Zen of Python, we have this maxim that says errors should never pass silently unless explicitly silenced. And I would add fail fast, noisily, and early. An example in OpenWhisp 2 is there is a configuration which if it's not set correctly, it just causes the app to not load at all, and it says this setting must be set. Rule of economy, and which was programmer time is expensive, conserve it in preference to machine time, which really boils down to do not spend too much time in premature optimization. Think about this. When Unix was born, this idea was radical because at the time, assembler was the norm. C was considered a higher level language. So Python is a consequence of the success of this idea. So let's embrace this concept. Rule of generation. When you find yourself writing lots of boilerplate code, try to use metaprogramming or code generators. And we have a metaprogramming example in the URL patterns, but I don't have much time left, so I will skip, and you can, if you are curious, you can see the slides online. We also, as a metaprogramming example, we also automatically generate the UI for the configuration from a JSON schema. This is an example. And we made the CSS make it look very similar to the rest of the Django admin interface. And the rule of optimization says prototype before polishing and get it working before you optimize it. And just publish your stuff early and start using it in the real world, and then start to refactor and polish. Don't be too much of a perfectionist. Even though Django is the web framework for perfectionists with deadlines, but perfect is the enemy of good. So following this rule allows you to have the best of both worlds. Rule of diversity. Distrust all claims of one true way. Try to maintain a skeptic attitude towards dogmas and fads, and measure the effectiveness of an idea or an approach before embracing it. Rule of extensibility, designed for the future because it will be here sooner than you think. And this is one of the most important concepts in this presentation, because if you want your app to be reused and extended, you have to provide some base models that can be reused in extension apps. Let's also call these third-party apps, but third-party apps can also be your own wrapper apps that become more complex as the complexity gets higher. So when you provide these models, store them in a Python file which is not called automatically by Django. Otherwise, Django will break down, telling you that the app is not loaded in installed apps. Try to separate the base model from the concrete models. The concrete models go in the standard Django models location, and the base model go in a slightly different location, which is not called automatically by Django. I provided some links to see examples of this. We have two Django apps that do this. Do the same for the admin. You can provide base admin classes, especially if your base admin classes are enough polished. And the same applies. Store the base admin in a different location than the concrete admin, so they can be called by third-party apps without breaking Django. And we also have examples for this. And views, try to provide generic views. If you want your app to be reused in third-party apps, you will need to provide some generic views on which the third-party apps can extend and add their own logic. And the same applies to store these generic views in a way that they don't call concrete models. Am I done?
You have 5 minutes left.
Okay, I'll try to go fast. We also have examples of base views, reusable URLs, because if you have views, you surely have URLs that many times are duplicated. So we do something, a little trick in which we have a function that we pass the views and we get the URL patterns. So we don't need in the more complex apps that call the smaller apps, we don't need to repeat that logic. And the app config. If you have an app config that loads signals, for example, third-party apps might need to hook their own custom models. And here we have an example of this. We call the base config app, and there is a method in which we import our custom models and we set them here, so the rest of the logic can then connect to the signals. I'm sorry I had to go fast on this, but you can check the slides and check the links. There is the code online on GitHub. You can do this with a lot of tranquility, and you can ask questions later if you want, or online. And now I want to quickly go through the positive results which we achieved by using this approach. We have a faster release cycle and evolution, and we have easier maintenance, because once a bug is spotted, it's easier to fix, especially in the configuration engine. We already have derivative work, even though this new generation of modules was released recently. We already have a couple of derivative works, and we have growth because the user base has been growing, and they have been sending feedback and patches. This is a graph of the activity of the mailing list, which is going very well. We have been accepted in the Google Summer of Code as a mentoring organization, and we are very happy of this. But it's not all a bed of roses, because there are a few problems. When you combine all these Django apps, you might incur integration issues that are not called by unit tests. So in this case, the solution is write more integration tests. As a shortcut, in a specific case, I was able to just import the unit test of another app, of a base app, in the integrating app, and to repeat them. And this fix was very good because it was a few lines of code. So if you write your tests in a certain way, in a way that they can be imported by other apps, it's also easier to write integration tests. Big features. When I needed to introduce a new major feature, I needed to change at least a couple of modules. Solution, many times this will be necessary. And if you have to change many modules every time, you have to consider refactoring your code to be more loosely coupled. There is a repository management overhead, because working with many repositories can be overwhelming, because there are more Git tags, PyPy releases, versioning, change logs, and you will have to announce more often new releases. And as a solution, you can import this project in a single window of your editor, which is easier to manage. You can automate versioning and change logs. I don't do this yet, so if you have any suggestion on how to do this, please talk to me. And if you release many small bug fixes and small things that users don't care much, don't even bother announcing them, because otherwise you will spam them with all these minor release update for small modules that they don't care. Another problem we have right now is the fragmentation of the documentation, because all these modules have their own readmes and docs, and we don't have a single documentation website yet. So to solve this, I added links to specific modules from the website, and I often have to send those links on the mailing list when people ask questions. But a central comprehensive documentation website would be better. Bug reports, because users don't know where to send bug reports, and they write to the mailing list. So for the moment, I just reply on the mailing list by pointing them where to open issues. But a single issue tracker for all the repositories would be better, even though it might not really solve the which module problem. There is a dispersion of popularity. We no longer have a single popular repository with many GitHub stars, and the solution for this is stop caring about it, because GitHub stars are not an accurate indicator of the success of a project. So, wrap up, the creators of Unix are not newcomers. Following their heritage is a good idea. I suggest you to look for further resources on the Unix philosophy and related concept. There are two books, Art of Unix Programming by Eric Raymond and The Pragmatic Programmer, which if you haven't read, I really suggest you to read them, even if you know this concept fairly well. And I suggest you to practice this philosophy and start to gradually apply this concept in your projects. For example, start extracting big features to separate projects. Say no to dogmas, practice empirical skepticism, test your ideas, measure your results, and try to read some code. Read the code of OpenWisp, or you can also take a look at OpenStack, which is a more complex but very valid, modular, successful open source project. And use the Unix philosophy for the win. If you have any idea, critical feedback, suggestion, talk to me. You can find me on social media. I publish the slides on SlideShares, and I will tweet them right now, so you can find them easily. And for those of you who won't go to the Fiorentina stick party, if you're interested, tonight I have a workshop about OpenWisp at another location. Thank you very much for following my talk. And I don't know if there is time.
Thank you very much, Federico. Unfortunately, we have no time for Q&A because the setup of the room needs to change. So once again, thank you very much. And we have now the lightning talks for anyone who's interested in joining that.